Okay, so for 6.4 notes, we're going to be talking about something called dilations. Okay, so you guys can just glue this in, or tape, or staples, or whatever you need. Okay, these are, you're going to have 3 examples here, and the tiny one is the first one. Okay, so the tiny one is the first one. Thank you. That doesn't work. No, it does not work. Check it out. There you go. Okay, I don't have any more. So you guys are going to have to share a glue stick. Okay, there's one in front. Just put it in. Okay, so first, so like I said, we're on unit 6.4. Okay, and we are talking about dilations. Does anyone have any idea what is a dilation? Any ideas? So you want to use the tiny one first. The tiny one is the first one. So dilations. Has anyone ever heard of that word? No, we're not going to be moving anything. Dilations are either to expand something, so enlarge it, or reduce it. Okay, so dilations is either enlarge or reduce a figure. Enlarge, or instead of reduce, we could say shrink a figure. Okay, can you think of any like real world examples where you might enlarge or reduce a figure? You guys ever heard, have you ever been to the eye doctor? Here they're going to dilate your eyes, dilate your pupils. Okay, dilation. Right, when you go to the eye doctor, they take like the really dark part of your eye. They might put some drops in there and it makes it really big. Yeah, it's your pupil. I don't know if everyone knew what that meant. Okay, they make it really big and then you have to wear like super funny looking glasses when you're done because your eyes are really, really light sensitive. Afterwards. Hello. Why? What happened?
Whoa.
I know. Sorry. Okay, so enlarging or shrinking a figure. So you could think of like we dilate your pupils. Okay, that means it's enlarging. Or have you ever like on your smartphone? Okay, you take a picture. If you take the picture like to get it printed or to get like a bigger print, okay, that's an enlargement. That's called a dilation. Can you think of anything going the other way around where you might have something and shrink it? Not your shirt. That's not exactly what we, okay. Shrinking something like, did you guys ever do a mission project in, I think it's like 4th grade, where you go to the mission and then you have to make a model at home? You ever done that? Okay. Or like if you're going to make a model of like if you were an engineer, or if you like if you guys have ever been to like if you're going to buy a house and you see like the little model like in the showroom or something, okay, those are all examples of dilations. Okay, so dilations are enlarging or shrinking a figure. So for example number 1, okay, example number 1, if I ask you to dilate by 3 using center of 0, 0. Dilate by 3. So what this is right here is this is called a scale factor. Okay, and a scale factor basically tells you how much bigger we want to make something. Okay, so if it's a bigger number than 1, that means that we are going to enlarge something. So we want to make this 3 times bigger. Okay, if it's a number less than 1, if it's a fraction, that would make something smaller. Okay, if you're multiplying by a fraction, it makes the number smaller. So this is called the scale factor. So the scale factor here is 3. So what you have to do in order to work these out is, first thing you want to do is you actually need to label these points. Okay, so if we label these points, or give me the coordinates, I'm going to really, really enlarge this one. And hopefully you can see it pretty decently on your paper, okay? What point is right here? If I want to ask you to name this coordinate. 3, 1. Okay, so 3, 1. Down here is what? 0, -4. And over to the left is what point?
Negative 1, 2.
-1 up 2. Okay, so first step in a dilation is to label your points. Okay, and if it was a quadrilateral or a rectangle or something like that, you might have more than just 3. Okay, then we're going to make kind of a little chart. Okay, we're going to write your original points. Then in the middle, we're going to have the scale factor. Go back and make this a little bit smaller. So your original points, then the scale factor, and then your dilation. Okay, so you're going to list your original points. So and it doesn't matter what order you list them in. So -1, +2, 0, -4, and 3, 1. Then our scale factor here was 3. So we have a scale factor of 3 for all of these. Basically, all you have to do is you take each part of the point and multiply it by the scale factor. So -1 times 3 gives you an x coordinate of -3, comma, 2 times 3 is 6. So you're going to multiply each part of the point, so the x part and the y part, by the scale factor. So what would your next point be after its dilation? 0 times 3 is 0. -4 times 3 is -12. Same thing for this one. 3 multiplied by 3 gives you 9, comma, 3. Okay, then the last part that you have to do here is actually plot the points. Okay, so this is my original figure. Remember, I'm going to make this 3 times larger. I'm dilating it by 3. So plot these points. -3 up 6. Thank you. So left 3 up 6. So over 3 up 6. And you can either count these, or this one is labeled with little numbers. Okay. I also want you to label these. So -3, 6. So while you're plotting them, I want you to label them as well. Then the next one is 0, -12. So remember, that means over 0, down 12. And luckily this one is labeled. So 0, -12. And then your last point is over 9, up 3. So over 9, up 3. Then once you have all your new points on there, or your dilated points, connect the dots with lines, and you're done. So basically what this means is we dilated this figure, we made this figure 3 times larger. That's what a scale factor is. Okay, all of your questions are going to say using center 0, 0. When you get into like math 1, or I think it's actually in stuff for math 3, so in like quite a few years, you're going to have different centers. For right now, it's just something that we have to write, but it doesn't change anything for you. Okay, it's not going to change anything at all. So we are always just, this is the only number that you really need to pay attention to. That's your scale factor. Okay, anyone have a question on how I did that? Not too bad, right? So we're just doing a lot of multiplication today. Okay, so for example, number 2, and we're only going to do 3 of them. Number 2, sorry, make this not quite so big. I would like you to dilate by 1/3. And again, just for formality, this is going to say using center of 0, 0. Dilate by 1/3 using center at 0, 0. So we're going to do the exact same thing that we did last time. Okay, you're going to make a little chart, and it is the original points, scale factor, and you can just write SF for scale factor, and then the dilation. So we're going to make ourselves a little chart here. Then we need to label the points. So what point is out here to the right? What's that coordinate? 3, 3. So 3 over 3 up. Over here is 3, -3, so 3 over down 3. And then this is -3, 0. Make sure whenever something's on an axis, people seem to have some trouble with writing that point. So you're always, remember, you're always going side to side, then up and down. So this is over 3, up 0. So write in your original points. So -3, 0, 3, 3, and 3, -3. Then our scale factor is 1/3. So you're going to multiply each of these parts of these points by 1/3. Now, if you need to, you could show work. Okay, so for like this first one, it's really -3 times 1/3. So what does that give you for your x coordinate? What's -3 times 1/3? -1. Okay, you guys can do this. And then what's 0 times 1/3? 0. Remember, anything multiplied by 0 is 0. So your first point is -1, comma 0. Okay, do you feel like we need to show the work for this, or can you do this part in your head? If you're capable of doing it in your head, that's fine. Okay, you're not using calculators on this. Can't really put fractions in calculators anyways. Okay, it's not very easy, and you're still not using calculators, okay? Then, what's 3 times 1/3? 3 times 1/3? 1. 3 over 3, which is 1, comma, 3 times 1/3 is another, just 1, so that's your second point. Then again, 3 times 1/3 is what? 1 whole, and -3 times 1/3 is what? -1. Okay, then we're going to take these 3 points, plot them on your axis. So -1 up 0, so left 1 up 0. Again, I want you to label these points. So -1, comma 0, over 1 up 1. So 1, 1, and then over 1 down 1, -1, 1. Then once you have your 3 points, connect the dots to make a triangle. So this is dilated by 1/3. So if you're dilating by a whole number, that means it's getting bigger. If you're dilating by a fraction, it's getting smaller. Okay, so dilations are getting bigger or getting smaller. Would you say that these are congruent? Are the two of these congruent? Your original figure and your dilation? Are these congruent? What does congruent mean? Equal. Are these the exact same size? No. Okay, these are what are called proportional. Okay, so you multiplied by the same thing to get from the big one to the small one. But they are not congruent. Okay, congruent figures mean same shape, same size. And these are not congruent. Okay, so like all of the other types of things we did when we just slid something, so a translation, or if we did a reflection, or if we did a rotation, those are all congruent. Okay, these are not, because they are not the exact same size and shape. Okay, they're the same shape, but not the same size. Okay, last one, number 3. Okay, for example, number 3. For this one, I would like you to dilate by 1/4. Dilate by 1/4. And again, we're always going to say using center of 0, 0. Dilate by 1/4. So your original, your scale factor, and your dilation. So the first thing you want to do is label your points. So what coordinate is way out here? 4, comma what? 2. Over here would be -1, 2, 3, up 3. So -3, comma 3. And finally, this point is what?
-2,
-2, -3. So if you write down your points, -3, 3, 4, 2, and -2, -3. My scale factor is 1/4, so you multiply each part of those by 1/4. They're looking for who? He's not here. Yeah, okay, thank you. Okay, so -3 times 1/4 would give you what? What's -3 times 1/4? -3 over 4. You will get fractions here. Okay, and that's just fine. We are going to get fractions here. Then do we need to show our work for what's 3 times 1/4?
That's 3/4.
Positive 3/4. So -3/4, positive 3/4. Okay, you guys are capable of multiplying by fractions. You do not need to worry about a calculator. Okay, remember, you're just multiplying the tops, multiplying the bottoms. 4 times 1/4. What is 4 times 1/4? 1 whole. Comma, 2 times 1/4, gives me what?
1/2.
2/4, okay? Which, yes, then you would reduce to be 1, 1/2. Okay, you do want to reduce that. And then the last one, negative 2 times 1/4 would give you what?
Negative 1/2.
Gives you negative 2/4, which you would reduce to be negative 1/2, comma, what's negative 3 times? Negative 3/4. Okay, so the difficult part that the part that people usually find difficult is the plotting of these. Okay, so if you look at it, where's negative 3/4? Positive 3/4. Where's negative 3/4 on this line? What two numbers is it in between? Which two whole numbers? Between 3/4 is in between 0 and 1. So it's the same thing on the negative side. So negative 3/4, so in between 0 and 1, it's not going to be what on what we'd call a lattice point. So it's not going to be on one of the crosses. So it's going to be in between, and that's okay. So negative 3/4 up 3/4, so again, in between 0 and 1. So it's maybe like right there. Okay. The reason this is okay is because you're going to label it. So negative 3/4, positive 3/4. Okay. So they're not going to be on like where the lines cross, and that's okay. Just as long as you know that if it's like over 1, so like 1 1/4 or something like that, make sure you're putting it in between the correct two whole numbers. Then over 1 up 1/2, so over 1 up 1/2, like about there, and you can kind of estimate it, and that's okay as long as you label it. And then your last one is negative 1/2, so left 1/2, down 3/4, so maybe right there. And as long as you label them, that's fine. So negative 1/2, negative 3/4. Okay, you will get fractions on your work today. That's all right. Okay, you just plot them in between the closest two whole numbers. Okay, does anyone have questions on how we did any of that? Hopefully not too bad. Okay, your homework for tonight is going to be worksheet 6.4. There are, I think it's 8 problems, okay? Make sure that you label your corners. Label your vertices on these, okay? They